We're going to review the patterns again that we already have developed in our Flet Python class. Some of it with FastAPI, although the UI has been with Flet. One of the key things is that when you advance after this class, you might be using FastAPI, Flask, Django, or Node. These concepts are going to be the same regardless of what UI and backend you're using. This async and await is a universal pattern for non-blocking code, which you're likely going to need to use to keep the UI responsive while you are waiting for the responses from the LLM or external API, such as a web search or a database access. The streaming is going to work very similar on any HTTP-based system, which is the most common protocol, although there are others. Real-time updates as coming up to the screen, regardless of what you're using, web, mobile, or desktop. The concept of updating the screen in real time or a portion of the screen is going to be the same. What you need to do is to practice using the concepts on whatever UI or backend that you want. For example, you could practice it with Flet and then attempt to apply it to the framework that you choose to use. Most systems will have an async pattern to define the function for asynchronous communication. This is the same with Flet, FastAPI, Django, Mobile, Flutter. They all use async definition. It may not be this exact word, def, depending on the language you're using, but the concept is the same. You may see the exact word async. You can use HTTPX with any asynchronous Python framework, so including Flask or Django. But this concept of using an asynchronous client will work with any other language as well too, to get a stream. The syntax will be different, but the concept will likely be the same. The streaming response might be called different things. In FastAPI, it might be called streaming response. In Django, streaming HTTP response. In Flet, you might have a loop which has page updates, or you could be using web sockets. In FastAPI, which is our next course, there is a responses which is built into FastAPI that does have the streaming response. In a FastAPI, so this is a FastAPI application, we're setting up the FastAPI decorator here for the route here for FastAPI. This portion is going to look pretty similar, where we have an asynchronous function. We're using the same HTTPX in FastAPI, which is what we're also using in FastAPI. The syntax looks pretty similar. You haven't covered the yield. And then there's the streaming response, which is different. But the concept is the same. If you're using FastAPI on the back end, there's a whole range of UIs or client-side consumption that you can use. This is JavaScript using an event source, and it's the same async pattern. However, there's a different transport. We used Jinja 2 in the intro courses for FastAPI with our FastAPI stack, and it's in an HTML format with embedded JavaScript. So this is this extension of the code from above. It's just on a different slide. And here we're using the event source. So it's the same concept that we've covered in Flet. In FastAPI, we are using a technology called HTMX, which is getting increasingly popular, although it's not as popular as using, let's say, vanilla JavaScript or something like that. It's used to simplify the streaming. So in server sent events, the events are unidirectional and persistent HTTP streaming. The server pushes the data over and the client kind of just waits there and listens for it. The connection stays open and the the data is delivered incrementally as events. So this pattern that we cover in the next lesson is often used for LLM streaming, which is what we're doing right now, progress updates, live logs, or status feeds, which we cover all of them in the next lesson. One of the reasons we're using HTMX is that simplification, and it handles the event source connection automatically. React is pretty similar to Flet. It even uses the use state, which is pretty similar. There's the async await keywords. It's going to the endpoint. The body looks pretty similar as well too. This is a continuation of the React code example, and we're dealing with the chunks. We have the for loop. In Vue, there's the component with the streaming. This is a continuation of the Vue code up here. It's in a while loop. Once you get the chunk and know what's in the chunk, you can then work with the chunk regardless of what language you're using or what framework you're using. So Flet does use WebSockets in the background, and unlike server sent events, it is full duplex, means that it's going back and forth. And if you do need more back and forth, there is a WebSocket for FastAPI package that you can use for the communication. And if you do want the full duplex, so it's back and forth, persistent connection, you can build a client in, for example, JavaScript. Django also does have a async WebSocket consumer, and you can see that it's pretty similar to what we've been doing. Once you start to understand the basics of the HTTPX or whatever HTTP connector you're using, and you understand the response from the Llama server, you can quickly adapt it to another framework. So for example, this is from Django, but if you just looked at it without the top portion there, you'd probably think it was just the Flet or the Python app that we were working on. Flutter would be a pretty solid choice for streaming, especially for mobile apps. And although the Flet actually uses Flutter in the background for the technology. Here's a quick example with React Native. The purpose is just to show you that they're all relatively similar. You do have to understand the concept and then apply it to the framework that you're using yourself. In the FastAPI course, we do focus on server-sent events because it's simple, HTTP-based, there's automatic reconnection. It's one way from the server, the FastAPI server, to the client that we're using at Jinja 2. However, it's only one way. It's not bidirectional, and it's a text-only format. WebSockets, which we don't cover, it's full duplex. It's what Flet actually uses in the background. Binary support has lower latency. There's more complex setup, and it requires a persistent connection. So we had some problems with the persistent connection with Flet on the LeapCell free tier, the hobby tier. We couldn't deploy it, so we had to deploy it on fly.io. So this WebSockets, because it's heavier, some of the free services, it may restrict the use of it. We're doing the HTTP streaming right now. It'll work with anything. It's a one-way communication only. There's no automatic reconnection. Since you're taking this course, I'm assuming you're using Python, and our next course does focus on the server-sent events. because we're primarily dealing with LLM or AI communication. So we want this type of a live chat as well as notifications as to what the AI is doing. If you did want to build more advanced gaming with the AI, which we may cover more of this, you might want to use a WebSockets, although it is more complex. What we have covered to date is the HTTP streaming. It's a simple request response streaming, so it's perfect to get started with. Doesn't require any special infrastructure. Mobile apps with the Fetch API, and it's great for AI chat or file downloads. It's probably the one to get started with. As we move to FastAPI, we'll be using the StreamingResponse. FastAPI is native async, and it has pretty easy and nice integration with server-sent events. It's great for modern Python web apps. Our background did come from Django. Django does work, absolutely does work. There is this channels for WebSockets or streaming HTTP response. It does require the asynchronous gateway interface for async, but that's pretty easy to set up. And it's good for existing Django projects. You can absolutely add it in. We moved away from it because we were having some problems retrofitting it onto existing projects, and we just wanted to start new with FastAPI. But you could build a new project with Django, absolutely. There is Flask SSE, or you could build your own, and you can also use async views with Flask 2.0. Flask is generally simpler to set up compared to Django, but then you have to set up all your other things like the database and other things that does come very nicely with Django. The async await pattern works in Python, JavaScript, and Dart. The streaming is the same concept across all frameworks. Non-blocking, you have to, especially in Python, it's a little tricky because a lot of the packages are synchronous, and so you have to make sure that everything within the async function is async, so that like a separate package doesn't block it, like a database access, if that's how your application is built. But once you get it working properly, you'll have a much better UI experience. So this will be a great segue for you to get to take the FastAPI course, which is also free, and try out FastAPI with SSE, or you could just do it on your own. You could also, if you want to learn React, we don't have a course for this, but you could build a React component with streaming, experiment with HTMX, which is in our FastAPI course, create a WebSocket version. You'd have to research this on your own. Or if you have a framework that you want to use, I suggest that you practice using that framework with this concept.